Hello, algebra students. Mr. Lawrence here. Who else would it be? Come on, ladies and gentlemen. By now you haven't figured out it's me. Come on. All right. Hey, we're going to be graphing linear inequalities and solving systems of linear inequalities. Should you have that word linear in there? Sorry about that. But before we do that, I want to quickly review if we had just a plain old inequality like this, it kind of looks like an equation, and we would solve this by listening to Saddam, right? Subtract 1 from each side, and then we would get 3x is less than 6. And then I would divide by 3, right? Remember doing this? Just review, x is less than 2. And then I have to show 2 on my number line, and I might put 2 other numbers on there. Okay, now I need an open point because it's not equal to, right? An open point. And then I got to fill in the blank. I got to use a test coordinate. I got to say, what is less than 2? Well, is it 1 or is it 3? Well, 1 is less than 2, and so then I would shade in the direction of the 1, right? Remember solving that kind of inequality? Okay, when we go to graph a linear inequality, it's going to be similar, only we're going to be doing it on a coordinate system. So what we're going to do, we've got this problem number 1 here. Looks like it's in slope-intercept form because y is lone. The only difference is it's a less than or equal to, right? So I'm going to find the y-intercept, which is at 0, -3. And I'm going to go 1, 2, oops, wrong way. 1, 2, 3, right there. I'm going to plot that point, 0, -3. And then I'm going to do a rise and run. So my slope was what, 2 over 1? So I'm going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Okay, now it's equal to, so I'm going to make a normal line just like I would if I were graphing. Now here's the only thing that's really different than the regular graph on this particular problem anyway. We're going to use a test point just like we did on the number line. I love to use the origin as my test point. Only problem is you got to make sure your line doesn't go through the origin. But I'm going to plug in, the coordinates of the origin are what? 0, 0, right? I'm going to plug 0 in for the x-coordinate and 0 in for the y-coordinate into this inequality right here. If I get a true statement, I'll shade the side of the line that the test point is on. Okay, it's just like the number line. I'm going to shade towards the true answer or the true statement. If I get a false statement, I won't shade that way. For example, let's go back to this one real quick. It said x was less than 2. Is 5 less than 2? And notice 5 would be over here, and there's no shading over here. It's the same thing on this linear equation. So I'm going to plug 0 in for y. That'll be less than or equal to 2 times 0 minus 3. I'm going to simplify this as much as possible. 0 is less than or equal to 0 minus 3. That means 0 is less than or equal to -3. Is that true? Is 0 less than -3? No, it's not. So I'm not going to shade where 0, 0 is. I'm going to shade the other side of the line. Ooh, maybe I'll use some crayon for this. Where's my crayon? Get my crayon out. Yeah. So I'm going to come over here, and I'm going to shade. See, by shading, I'm trying to find all the solutions to the inequality. You pick any point over here and plug it in, I guarantee you'll get a true statement. Go ahead, pick one. Go ahead. Go ahead. What point do you want? What's that, Kevin? You want to try the point 5, -2. So let's see here. 1, 2, 3, 4, 5. 1, 2. You want to test this point, right? That's the point 5, -2. Good choice, Kevin. Let's put -2 in for y, right there, is less than or equal to 2 times 5 minus 3. Simplify the right-hand side. I'm going to get 10 minus 3. Continue to simplify the left-hand or the right-hand side, and I get 7. Is -2 less than or equal to 7? Sure is. And so therefore I shaded where that point was. Yeah, if I pick any point over here, I'll get a false statement just like I did for the origin. Now remember, if the line goes through the origin, you can't use the origin as a test point. It'll fool you. Here's another one. This one's in standard form, so I'm going to go A, B, C. Easy as 2, 3, 4. And I'm going to find my slope. That'll be negative of A over B, right? And I think I'm going to find the x-intercept because 2 goes into 4. So I'm going to make that little table, right? And I'm going to plug 0 in for y. And when I do that, I'm going to get 2x plus 3 times 0 is greater than 4. This left-hand side is going to simplify to 2x. 2x is greater than 4. Divide by 2, and x will be 2. Okay, now it says greater than. When I'm testing, it's really only equal to, but that's okay. So 2, 0 is my x-intercept. So I'm going to go here at 2, 0, right? And my slope is negative 2, 3. Down 2, run 3. I could rise 2 and run negative 3. That would get me the same line. Wouldn't rise 2, run 1, 2, 3. Okay. So this is not going to be a solid line. It would like be a series of open points, only what we do is we show a dashed line. Why is it dashed? Because it doesn't say equals to. Yeah, no kidding, it's that easy. In a number line situation, if it's not equal to, we leave an open point. In this problem, since it's a linear inequality, we just make the line dashed. Now I still have to do the test point and find out which side of the line to shade. And again, I like the origin. I always like the origin. So I'm going to go 2 times 0 plus 3 times 0 is greater than 4. Well, this whole left-hand side is going to be 0. Is 0 greater than 4? No, it is not. So I'm going to shade the other side of the line. So I end up shading like this, meaning all the points on this side of the line forever and ever and ever are solutions. They will all yield a true statement if I plug them in. Okay. Now, if we have to do a system, I apologize about those colors, but there's something cool I'm going to do with this. If I have to do a system, it's the same thing, only there'll be 2 shaded regions. Now, watch what's going to happen. I'll do the blue one first. The blue one's going to A, B, C. Easy as 3, negative 4, 8. And it looks like my slope is going to be 3/4. And I'm going to go find the y-intercept this time because the b term goes into the c term evenly. So I'm going to put 0 in for x, and so that's going to give me 3 times 0 minus 4y equals 8. That's going to cancel. Divide by negative 4, divide by negative 4. Y is going to equal negative 2. So my y-intercept is at 0, negative 2. And my slope was rise 1, 2, 3, run 4. And rise 1, 2, 3, and run 4. Okay, now it's not equal to, see that? It's not equal to, so this will be a broken line. So let me get my line out here. And let's see here. Okay. All right, and I'll make it blue so we don't get it mixed up. I'll make it a little bit thinner. Okay, now I got to do the test point. Got to do the test point. Always have to do the test point. Okay, so I'm going to plug 0, 0 in. So I'm going to have 3 times 0. What the hookah waka is that? Let's try this again. It's because I was trying to write while it was moving. 3 times 0, and it's minus 4 times 0. And is that greater? It's less than 8. Is that true? Oh my goodness. Less than 8. Well, the left-hand side will simplify down to 0. Is 0 less than 8? It sure is. So this time, I'm not going to highlight or color in crayon. I'm going to do it in highlighter. And so I'm going to shade all over here. And I think this is like the bee's knees. I know I'm dating myself with that expression. But anyway, so I'm coloring in. It's I don't have to be perfect at this. So I understand that the shading is everything above the line. Okay, now I got a little smidgen below the line, so I'll try to take care of that, see if I can without doing too much damage. Okay, close enough. All right, so now I'm going to go and do the yellow one. And that's going to be a little bit easier. The y-intercept on the yellow one is going to be at 6, right? Okay, so it's right there. And the slope is down 1, right 1, 2, 3, 4. Down 1, 1, 2, 3, 4. Now, it's cool that they crossed at a point you're expecting that to happen. That won't happen a lot with inequalities, but it's okay if it does. So I'm going to need a solid yellow line here because it is equal to, I've only said that like 8,000 times. 1, 2, 3, 4. Yeah, that's right. So it's going to go like that. And since there's some shading involved, I'm going to try to make this go real long here. And I'm going to make it yellow. And the cool part is coming up here. Hold on a second. All right. And make it a little bit thinner. Oh, and I want it yellow. There we go. Okay, now I'm going to shade. I got to do a test point. So I'm in yellow. Again, I can use the origin. So I'm going to show my work down here. So I'm going to have 0 is not what I wrote. Try this again here. 0 is greater than or equal to negative 1/4 times 0 plus 6. Is 0 greater than or equal to the right hand side will simplify to 6. Is that true? No, it is not. So I'm going to shade on the side of the line that's away from the origin. And so I'm going to come over. Oops, wrong color. Sorry about that. Let me just get rid of that. Sorry. Okay, so I'm going to start shading over here and watch what's going to happen. Ooh, blue and yellow make green. The solution to this system of inequalities is the green. Yeah, it's everything that would be green. So it's all the stuff above to the left of the blue dotted line and all the stuff above the yellow solid line. It's all that area there. And I just love doing this because it's so cool that it turns out that way. Yeah, so you see, now you're going to do it with pencils, and I'll demonstrate it for you in class how to do it. But on the airliner or on the smartboard, it looks so darn cool, especially for a math geek like me. All right, so let's see here. Excuse me. I got the blue equation in standard form. And so I'm going to go ahead and find the x-intercept and y-intercept. This is one of those easy ones where I'm not going to use this. So I know that the y-intercept is going to be at 5. So right there. And I know the x-intercept is going to be at 2. So looks like my slope is down 5 and right 2. And then down 5 and right 2. It's going to be a solid line because it's equal to. Okay. So it's going to go like that. And let me put an arrowhead on there. And I'll make him blue. All right. And then I'm going to test the origin because the line doesn't go through the origin. So I'm going to put 0 in for x. So that'll be 5 times 0 plus 2 times 0 less than 10. Yeah, I think that's going to be true because I'm going to get 0 is less than or equal to 10. Absolutely. So I'm going to shade the origin side of the line. So I'm going to be shading all of this. Ooh. Now I got a little sloppy there, but we understand that we're doing everything underneath the line in this case. All right, now I'm not going to teach you a shortcut about, oh, shade this way if, I don't like those shortcuts because they're only true 50% of the time. And so then kids just want to rely on that shortcut and they don't understand what they're doing. And then they don't know what to do when it's the time where it's not true. So let's see here. Okay, so now I'm going to do the yellow one. Now the yellow one's not in slope-intercept form, but it's close to it, so I'm going to get it to slope-intercept form by dividing by 3. When I do that, I have to do that in all 3 places, right? So I'm going to get 4 minus 2/3 x is greater than y. So the y-intercept is going to be 4, and my slope is negative 2/3. So down 2, right? 1, 2, 3, and down to 1, 2, 3, like that. This one will be a broken line because it's not equal to. I've only said that like 85,000 times. All right. And so let's see here. Let's put an arrowhead on that. Let's do that. Let's make them yellow. And then we will use our test point, right? Okay, so I'm going to plug into this equation 0 in for x and y. I'm going to go ahead and erase this work here just because it's in my way and I don't want to keep scrolling back and forth. So I'm going to have 4 minus 2/3 times 0 is greater than 0. All right, well, this is going to be 0, so it's going to be 4 is greater than 0. And that is true, so I'll shade beneath the line in this case. And when I do that, it'll look like this. Oh, look at that. All that is going to be green, everything. Okay, and there's the yellow. So, the region of the solutions is not limited by my coloring ability. You understand that the solutions, all the solutions, oh, that wrong button, all the solutions will be below this yellow dotted line. That means it would not include those points, right? Dotted line. And at the same time, to the left of this line. So it has to be both below the yellow dotted line and to the left of the solid blue line. All right, that's it. We're going to get some practice with this in class. I think you're going to watch this Tuesday night. No, you're going to watch this Monday night, so that'll be Tuesday in class. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.